So for this problem, we're asked to solve 1 over 1 plus y squared plus cosine x minus 2xy y primed equals y times y plus sine x with the initial condition of y of 0 is equal to 1. So both of these sides look relatively similar, but first we're going to split up the y primed. We're going to end up with 1 over 1 plus y squared plus cosine x minus 2xy dy equals y squared plus y sine x dx. And just so you can see where I got that y squared plus y sine x, I just distributed the y, and y primed is dy over dx, so brought the dx over to this side, kept the dy on this side. Now, to prove that they're exact, we're going to take the derivative of this side with respect to y and this side with respect to x. Now, our next step is going to be to put them all on one side, and we'll end up with an m and an n. So it's going to end up with 1 over y squared plus 1 plus cosine x minus 2xy dy minus y squared plus y sine x dx equals 0. So this is going to be our n, and this is going to be our m. We're going to take the derivative of n with respect to x and the derivative of m with respect to y. And if these are equal, we will know that the differential equation is exact. So the derivative of n with respect to x is negative sine x minus 2y. And we'll see if this equals my, which is negative 2y plus sine x. You distribute the negative and you get negative 2y minus sine x. And because they are equal, we get that this is exact. So since we know it's exact, we are going to take the derivative of one side. I'm going to choose side m because it seems the easiest. And first we're going to take it, we're going to integrate it first, then we're going to take the derivative. And we're going to integrate it with respect to x, so that's going to give us y squared plus sine xy, sine of x times y, not sine of x and y, dx. And that will give us y squared x minus cosine xy plus h of y. That's all going to be negative because it was negative in our original answer, or not our original answer, our original problem. Sorry about that. And so from here, we're going to take the derivative, and we're going to get the y squared, we're going to take the derivative with respect to y now. We're going to get the 2y x minus cosine x plus h prime of y. And so we know that h prime of y is going to be equal to our n. So we're going to set this all equal to our n. And squared plus cosine x minus 2y x dy. So we have m on one side with h prime of y, and the entire thing is equal to n of x, and we know this because the equation is exact. So from here, we can cancel things out. Negative and a plus. I forgot to distribute that minus. And so that will cancel out with that, and that will cancel out with that. And you will have that h prime of y equals 1 over 1 plus y squared dy. Our next step is going to be to integrate. We're going to get integral of h prime of y equals 1 over 1 plus y squared dy integrated. And if you know your trig, you will know that that is arctan of y. So now we're going to plug our h of y back into this equation. And we're going to get that c equals negative y squared x minus cosine xy. We have to distribute that negative, plus arctan y. And if you recall, we have the initial condition of y of 0 equals 1. So we need to plug that in. Right here we'll end up with a 0. Cosine of 0 is 1. And plus, it's going to end up being pi over 4 because the arctan of 1 is pi over 4. And you're going to get negative 1 plus pi over 4. And that will leave you with, let's just keep it as 1 minus pi over 4. Equivalent to negative y squared x plus cosine xy plus arctan of y. And that is how you solve an exact differential equation